Yeah, welcome to the lecture 15. That is historical chronology of the crop yield prediction. So, earlier lectures we have discussed about the terminologies in crop modeling and simulations. Also the goals of crop modeling. There are the two goals, scientific goal and engineering goal. And this the systems, how the you are looking at the engineering goal of crop modeling and simulations for application of crop models and the decision making process. So, here we will discussing about we should know that how the crop yield prediction system has developed over the years. So, that we will be discussing here the when it started, how the progressive changes has been taken in crop yield predictions, and now also this is a continuous and dynamic process. So, as per the need of the society, need of the nation, so the development is taken place as a throughout. So, with this let us start for this how this development has taken place, because in the face of the limited farmland and growing global population, so all these agricultural systems faces mounting complexity and the pressure on natural resources. So, so natural resources are getting depleted, farmland is getting reduced, and there is a scarcity of the water availability, the land degradation, the soil health is getting deteriorated over the years because of climate change. And this this what gives a challenge for the scientists or the engineers, how to increase productions with the limited resources. And to do so, that is why you have gone for the crop modeling as a tool to understand and the forecast the crop yield for different scenarios. So, which will give us understanding to devising out the management options, so that we can attain the maximum productions with as a resource efficient productions and sustainable production as well. So, over the 7 decades we can say 7 decades crop models have been developed for simply from the empirical models to process based models and then the AI integrated systems. So, we have discussed about earlier the type of models, what are the empirical models, what are the process based models. So, there is a continuous development process. So, this lecture will be explaining you the development phases of the crop modeling simulation, that gives a understanding how the system has started, and you should know also. So, the year when the starting year of the crop modeling, how the development or the has taken place and the additions, value additions has been done the crop modeling scenarios. So, why you go for crop modeling? Only thing I want to give a brief introduction. So, the use of the crop modeling I had explained of course earlier. So, to see the modeling and the because earlier we are doing field experiment for any informations we are generating through field experiment. It was of course is a time consuming expensive process, and there are some limitations of field experiment. So, as we are discussing here so now there is a need of the crop modeling, and this was realized because crop modeling can be introduced, is a must. This is as a complement for the agricultural research, can add value to agricultural research. How it can be done? Suppose you have the field experiment. Sorry. Field experiment and simulation model. You see, so conventional way, or you can see the beginning for understanding the effect of particular factors to arrive some conclusive decisions. So, we used to depends upon the field experiment. Now, also we are continuing this field experiment, and field experiment should continue also, that is, it should not stop. So, people should depend upon the field experiment. So, this gives the real world experiment, the exact accurate, the accuracy in the effect of particular factors, particular components, which gives us confirmations, and this must go on. So, field experiment, suppose you want to test the effect of factors, the parameters, you can see the variables are the suppose you can see effect of factors. You know the effect of factors. There are, so you want to see effect of the other parameters, effect of the there are factors, several factors you can say are weather or irrigation management, nutrient, so any factors. So, if you want to see the effect of a particular factor or the different factors, so we go for field experiment. You go for suppose to know effect of the other parameters on crop yield or the soil water balance or the nutrient uptake. So, what we can do, we do experiment in the field and we grow the crops with different seasons and different the planting window. So, that there will be change of the other parameters natural. Suppose if you go for the planting window changes from the 15 days or 20 days gap. So, there will be a change in other parameters appearance or the different growth phases of the crop. So, this will give us understanding the effect of weather on the crop yield, or we have to go for the controlled environmental experiment and we will have the different greenhouses where we can have the different weather parameters, we can grow the crop in same time, but vary the other parameters in different greenhouse and you can see the effect. So, in this way similarly irrigation, so you have to conduct the field level experiments, different irrigation regimes and see the effect of irrigation levels at the timing of irrigations or the quantum of irrigations on the crop performance. Same for the nutrient management, the timing of application of nutrients or the quantity of nutrients. So, on the crop performance we have to go for field experiment. So, in this case how many factors you can try, you can test in a particular time. In field experiment only limited factors you can try in one experiment. So, only limited factors you can try either weather parameters or irrigation, nutrient, and there are several other factors. So, tillage operations you can take n number of factors can be, you want to try test the effect of the n number of factors on crop performance. Tillage operation is there, seeding depth is there, pesticide application. So, n number of factors are there which you cannot test in a single field experiment. You need to, so however, in case of the simulation exercise or modeling, if you have a ready made crop model available, you can test the effect of any factors on the crop performance. So, simulation has a no limitation of factors, n number of factors can be tested on the crop performance. Either you can test the effect of the weather, irrigation, nutrient, tillage, seeding depth, pesticide applications, intercultural operations, weeding. So, whatever the factors you have, you can test the effect of the factors on crop performance if you have the reliable and the validated crop models available with you. Similarly, the labels. Labels means the, suppose each factor I can take the irrigation one factor, irrigation. So, there are different labels of irrigation, n number of labels. So, how many labels you can try? Suppose irrigation is a no irrigation 0 centimeter, 20 centimeter, 40 centimeter, 60 centimeter, 80 centimeter. So, how many levels? So, you want to see the effect of the increasing level of irrigation on the crop growth, crop yield, water balance, nutrient uptake also. So, how many you can try in field experiment? Only limited number of irrigation you can be tried in the field experiment, but for the model you can try any level of irrigations in 0, 10, 20, 5, 40, 45 and the timing of irrigation also that can be tried using a crop model. So, here there is no limitation. So, that is what advantage of the model. Similarly, the site means the locations. So, you want to see the effect of the locational changes. So, in India we have 15 agroclimatic zones, right, as I discussed earlier. So, you want to study the effect of a particular genotype on the crop yield and test the same genotype in 15 agroclimatic conditions, or effect of a particular input management, nutrient management on different agroclimatic conditions, because if you change agroclimate conditions, soil changes, weather changes. So, you want to see the effect of change in weather and soil on crop performance based upon a particular factors, maybe nutrient management. So, what you can do? So, you have to go and conduct experiment in different sites, different agroclimatic zones, even in the repeated experiment in one agroclimatic zones. So, that is a time consuming, and also you can go for you have only limited number of experiment you can do and you can manage, and also this is expensive. But having a model, if you have a model available, there you can give the inputs of the soil inputs, weather inputs for different locations, and then you can know the effect of a particular factors or the variables or the different labels on the crop performance. So, at different locations, different agroclimatic zones where there is no limitation of the sites, n number of sites, even the world level also you have model, you can go for simulation world level. So, that is what the advantage of having models over the field experiment. So, models are a complement, they do complement the field experiment. Using models and experiment, we generate informations, and the experiment should continue for the refining the model. Models need to be calibrated, validated, and for calibration validation we need to depend upon the experiment. So, experiment is a continuous process, they should go on, and simulation, using the simulation model, that adds value to the experiment. So, that is must, that should be to get the informations very quickly and limited in a limited time and limited expenses, and very precise information also you can get from the simulation exercises, and this will give a real time or the very quick decision making process for the agricultural production management. If you depends upon the complete on the field experiment, takes a long time. So, we do not want the field experiment completely to be substituted or the replaced by the simulation. No, field experiment is and simulation, they are complementary, they do complement each other. Simulation development takes place, simulation models calibration, validation, refinement, that depends upon the experiment, and experiment gives understanding about the developmental process, and they should continue go on to solve a particular problem and to have a decision making agricultural production. So, with this, so since this is essential for the now this has become very essential to use a model for any decision making process, because you can, because the purpose is you can try many factors, you can try many labels in the same factor in a model, which is not possible through field experimentations. With this, let us discuss how the model's development took place with years. So, from 1950, so there was a the model development started. So, 50 to now we are almost 2025. So, this is a continuous process. 1950, 1960 there are some concept for the model development, then 76 to 70, 7 to 80, 8 to 90, 9 to 2. Likewise, there is a continuous development process in the model. So, we will discuss from the how it started from the beginning 1950. There is a foundations of the crop modeling. This is the fundamental science, foundational science you can see that developed during 1950, because this modeling scenario was used for the other fields. So, this was not used for agricultural field. Then the scientists, and DeWitt and the Van Bevel, they could know took some steps, so computational analysis for the plant and soil process. They started this one. So, initiated the concept of representing biological process mathematically, how the process can be represented in mathematical functions. So, that they started to work on this one. So, it was particularly when for the crop yield simulations, whether the photosynthesis and the respirations, crop growth process, soil water balance, nutrient dynamics, those how this can be represented in the mathematical functions, the equations that they tried. So, this is beginning understanding of the crop modeling at the beginning of quantitative agronomy, that is linking to crop physiology which is environmental factor. They tried this on in 1950 to 60. So, this was the aim was to address the policy analysis for the rural areas and resource planning. How this if you go for the mathematical modeling, so that becomes a as a quick process and also gives a better understanding through this field experiment. So, this was this started in 1950 to 60, then 1960 to 70, then ecology and the policy needs this was identified. So, crop modeling slightly took shape where the on the water balance and the early photosynthesis models were developed. That is as ecological photosynthesis, respiration, biomass partitioning, how the biomass accumulated through photosynthesis process as a stomatal and leaf levels, and how they are partitioned to the different parts of the crop. So, those understanding was developed in 1960 to 70. Then International Biological Program promoted the global collaborations to look for the mathematical modelings. Then UK Newton modeling for the it took for the livestock and regional model network in the US and Australia. They took crop models began incorporating the ecological parameters and management practices, laying the groundwork, the base work for the modern agro-ecosystem models. So, this started from the you can say 60 to 70 or the early 70 to take place. From 70 to 80, so there is a satellite technology and system thinking, that is a continuous process developed. So, how we can simulate the entire agricultural systems. So, that is a FOO, it is a land evaluation, then it is agroecological zoning methods created, then how we can go for the livestock herd dynamic models and simulation based decision systems. So, livestock now also you can see now you are working on particularly crop models. So, the agricultural integrated farming system model also coming up, where the crops, livestock and other enterprises are also involved. So, this is development of livestock herd dynamic models also started developing, and the first journals you can say agricultural systems that was that came in 1976, because now here it talks about the different system simulations, particularly the input parameters, how they do interact with each other, and to get this the final outputs as per the user interest. It may be crop output, biomass or yield, water balance, nutrient balance, greenhouse gas emission. These are the systems how the agricultural system journals then try to develop initiated, and now you can find it has a very good journal and publishes most of the system related papers. So, you can also refer to these journals. Most of the agricultural crop modeling and simulation exercise are explained here, not only crops and the whole the farming system research also, not only the local levels as well as the regional and the global levels, the papers you can find from agricultural systems. Then early models integrated this then it was a biophysical and the management interaction that came. So, there is a to have the modern decision support system that tried 1970 to 80, where the process based models how can be integrated for this one. And 1980 to 90, there is a computing revolutions and process based model that took shape. We can say there is a significant achievement has been done, because this is the many models have been developed in the DSAT software DSAT platform. So, decision support system for agro technology transfer. This for the cereal crops, we have the CERES model, that is a crop environment resources synthesis. Then crop growth models, the different soybean crops, peanut crops, some legume pulse crops, crop grow models, and the SARP models also, particularly species area relationship, there is a simulation species extensions. So, how the locations that influence the species. So, that SARC model also they came in use in Netherlands. So, this was the then there is a formation of the establishment of ICASA, International Consortium of for Agricultural Systems Applications. And they are the scientists from different parts of the world. They joined together particularly for the data sharing and the model development, because what you say, so different in the global level. So, they because different regions have the different crops and they have the data set for the crops very specific. So, the scientists joined together to share the data, share the information on some particular crop and develop the crop model. That started the establishment of ICASA. That is a good program. So, under the ICASA there is a development of the DSAT models, the decision support system for agricultural transfer. So, that includes the various crop models for cereals, pulses, oilseeds, fiber crops and some of vegetables and fruits as well. Then the expansion of the process based models that started simulating the photosynthesis, soil moisture and nutrient dynamics of the during that period only, and the integration of the weather data, soil database management inputs became the standards as we are discussing. So, that is the process based model that started during 1980 to 90. So, crop modeling transition from the research experiment to predictive application. Really it started in the development models global level. So, there is so many scientists they came together. So, then it expands from this came that the crop modeling can be utilized in different parts of the globe, particularly DSAT models. There is several users and this is used all over the world, but for a particular crop that has to be calibrated and validated for the locations we are using that model. And see 1990 to 2010, and that is mark the broad applications and globalizations of the crop system models. So, that is a broadening and integration. So, what key development has taken place after that? So, integration of the climate change assessment, the first IPCC report came in 1990. So, then the to see the effect of the climate change on the crop productions of the different other parameters. Then GIS remote sensing tools were incorporated for the spatial simulations. That means if you want to see the effect of the variability in the soil, variability in the weathers and the crop yield. Suppose you take any crop you can take for Indian conditions. Suppose you want to see the effect of the yield variability, you want to judge yield variability because of the soil parameters or the other parameters or the management parameters you can say. So, if you go to different locations, the soil properties are different and the weather also different for different locations. So, if you have a DSAT models with GIS and remote sensing tools are there incorporated. So, you can see the effect of the varying soil parameter, varying locations, that is a varying yield. So, yield variability map can be created using the DSAT models for different locations. That is variability is because of the soil properties and weather properties. So, if you keep the management practices same, do not change the management practices. So, how the yield changes over the Indian all the if you say rice growing area, major rice growing area, use that model and it is a geographic information system and remote sensing applications. So, if you give the soil data of the different grid based data, the location data, then you can also weather data, we can have the yield map for different soil and weather. So, that gives the yield variability map of different locations that can be, that will give lot of understanding about the locational informations and the effect of the locations particularly on the crop, and through that understanding we can make the location specific management options. So, if you know the yield variability map for different locations, then we can go for the using the modeling exercise, we can go for the change the management practices. It may be it may be sowing time, it may be nutrient management, it may be water management based on the local conditions, locational situations. So, that is understanding, scientists can create the understanding what type of management you want to bring in. So, according to those management can be trained the models. So, using those management practices, we can come out the set of the management practices which can maximize production for a particular locations, that we can bring. Then this becomes a sustainable agricultural movement. In 2000s, emphasized the environmental impacts and resource efficiency. Then models began guiding the policy and resource management decisions. So, particularly as I was discussing, so using the models, you go for the as a predictions, yield predictions for the locations, and this should helps also the policy decisions for the government levels, because if you the model can give the forecasted future yield. So, based upon looking at the future yield, so decision can be made. So, decision can be communicated to the policy makers. So, that will help the government officials, government machineries, and regarding the management options to be communicated to farmers for different climate scenarios. And from 2010, so there is a AI and the food security emphasis are taken. So models are integrations with the advanced data. Now at the present we are doing so creation of the AGMIP, that is agricultural model intercomparison improvement project. So all over the world scientists have joined. So for a particular crop, so there is a integration of the models. So using different models, you are getting the yields and comparing and the yield variations, and also with the actual field level data. That gives a understanding. So which models has a better accuracy predictions, and what are the parameters changes can be made in the model, so that you can reach the accuracy. So, this is a example model intercomparison improvement. So, that makes a improvement of the project. So, that is a continuous process that goes on, that is going on all over the world. Then machine learning, then big data, that came cloud computing also. Now, current generation people are most they are working on this one. So, this gives a real time information and real time input management. So, machine learning and deep learning big data is used for particularly for the disease predictions. Now, if you go to identify disease and make control measure, it takes time. So, using machine learning now also we can give the recommendations for particular disease. It is a quick identification, what type of disease, what is the causal agent AG, and what type of control measure to be followed also, that can be given a quick decision using machine learning and big data. And application, that is to a real time yield monitoring. So, climate change adaptations, then food security analysis, definitely current focus on hybrid modeling, combining the process based and the also AI integration for the agricultural and the applications for the precision agriculture and sustainability. So, with this the summary and takeaway. So, this is a continuous development in the crop modeling process. Crop yield prediction has evolved through 7 decades of innovations in computations, ecology and system science. So, from the 1950 to 70, 7 to 19, 1920 and 2010 present. So, we are moving for the now the era of the AI. So, data fusions, data science. So, modeling is a, so since a model has developed, it is a good thing, no. So, modeling itself generates the huge information, huge data, and that can be used, that is well implied. So, this is used for the also AI can be integrated a better decision making process. So, modeling exactly see it is a decision making process. Decision is taken by the scientists or engineers. So, these are the tools that supports the decision making process, like now if you go to any medical practice, any physician doctor for the diagnosis. So, he depends upon so many tools for the analysis of the different symptoms. So, the modeling exercise are these are the tools that help in decision making process of the engineers or scientists for the better decision makings and in communication of decisions to the end users. So, that can help the proper management and proper planning of the agricultural operations for maximizing the productions and the sustainability of the productions. With this, I thank you all.